All right. Simply, we're going to discuss rationals. By that, we mean rational equations, functions, you name it. Just quickly to understand what's going on. Can anybody give me the definition of a rational number? What do we mean by rational numbers? Anyone? All right. Just, it's going to be fairly fast because we really don't have time for that. So let's discuss numbers. When we say natural numbers, what comes to your mind? 1, 2, 3 to infinity. Do you remember that? Whole numbers, just add a 0. 0, 1, 2, 3 to infinity. Every set has a definition. Do you remember that? Integers, what comes to your mind?
Negative.
Same thing, 0, 1, 2, 3 has whole numbers now extended to the negative side. Negative 1, negative 2, negative 3. Everybody remembers that? Rational numbers are numbers that can be put in the form of a fraction. But there is a restriction. The restriction is the top and the bottom are both integers. Remember that? Again, rational numbers, example would be 3 halves or 2.1. If you can put it in a form where the top and the bottom are both integers. So how do you prove number 2.1 is a rational number? You put it in the form of a fraction. We just proved it. Is everybody clear? Now, whether it's a mixed number or an improper makes no difference. Or if somebody says, okay, I'm claiming 7 is a rational number, the proof is very simple. This is the proof. What's the top? An integer. What's the bottom? Is an integer. Therefore, every number we've studied so far, meaning natural numbers, whole numbers, and integers are also rational numbers. Then we expanded to irrational numbers. Rational and irrational come together. The union of the two is the set of real numbers. So when we discuss a polynomial, when we discuss rational expressions, now what is the restriction? The restriction is the top and the bottom are both polynomials. Okay, now of course, by polynomials mean finite sum of terms like a sub n x to the power of n, where n is any whole number. Everybody knows, I hope you're familiar with the notation. This is an element of, and this is the set of whole numbers. Okay? So for example, if I said 5x squared minus 3x, we've discussed that, it's an example of a polynomial. Right, class? But if I said the square root of x minus 7, that's not a polynomial. Therefore, if I said x plus 1 over square root of x minus 7, not a rational expression. Got it? That's as far as a basic definition. I hope you've read that and you're comfortable. Now the question was, if we are given the following, everybody, and I'm going to call it f of x, if we are given f of x as x plus 8 over x squared minus 2x minus 63 we are supposed to find the domain and everything related to that. To understand the question, I want to go to a very basic idea regarding fractions. So let us look at the following fractions. Let's look at the first one, let's look at the second one. 2 over 0, let's say 0 over 2. What do you know about those two fractions? Anybody want to help us?
One is undefined and the other is...
Be more specific, which one?
The...
Say it again.
One with the 0 denominator.
So this is undefined, that's what you're saying. Right, class? What about this guy?
0.
Did we lose anybody? Now, the same thing can be extended to rational expressions. Unfortunately, that's a common mistake that students mix up the two. I have no idea why. But here's the idea that might help you. Couple of things about 2 over 0 so it will help you see why it's undefined. If you're dividing by 0, okay, there must be a number that is the answer. Are you with me? What number times 0 is 2? Can you think of a number that you multiplied by 0 to get 2? I can't think of one, therefore it's undefined. Okay? However, if you look at this one, if it's x, 2 times x is what? 0, so x must be 0. So it's easy to, I think, distinguish between the two. Now, of course, further down the line, when you learn more math, there is a reason that they call this undefined, because for all practical purposes, this 2 over 0 blows up. It goes to positive or negative infinity, okay? So this might help you remember this. Class, let's look at a simple example of 2 over 1. What's the answer? 2. Everybody knows that, right? Now, let's say 2 over 0.1. Anybody knows the answer quickly?
20.
Say it again.
20.
I hope you can do this in a split second, because for God's sake, you are intermediate algebra students. So now I'm going to divide this by 2. I'm going to divide this by 0.01. What's the answer? 200. So what's happening? Anybody can detect the trend here. I'm keeping the numerator fixed. I'm not changing it, right? What am I doing to the denominator? I went from 1 to 0.1 to 0.01, and I can continue. In fact, let me just pick one more. 2 divided by 0.00001, a bunch of zeros, and then 1. Anybody can give me the answer fast? How many decimals do you see at the bottom? Count the number of decimals. You can't even count?
5.
5 decimals, right? So I need 5 zeros. That was easy, wasn't it? So what's happening to the quotient or the result? We go from 2 to 20 to 200 to 2. Isn't it getting larger? So as the denominator gets smaller and smaller, how small is getting? It's getting closer and closer to what number?
0.
0. The result gets larger. It blows up. It goes to positive infinity. You got that? So eventually, when you learn more math, you're not interested in undefined, but rather whether it's infinity or negative infinity. I hope you understand what I'm saying, so it will help you remember why they say undefined. It blows up. Now, if one of those numbers, let's say the top was negative, are you with me? Would the result be positive or negative? So now it goes to negative infinity if we continue with that thought. Is everybody clear? If the top or the bottom, one of them is negative, the result is negative. So that's why it blows up, goes to infinity or negative infinity. Which one depends on the sign. Sounds good? So if you remember this, it will help you understand the concept. Okay? Why they say it's undefined. Now, let's look at this one. When you're looking at a fraction, everybody, an expression involving a variable, a fraction is 0 if the top is 0. A fraction is 0 when the top is 0. Does that make sense? A fraction is undefined if the
Zeros on
bottom is 0. So, if I ask the question, number 1, f of x is equal to 0, give me the answer. You say, I set it equal to 0, and therefore x plus 8 is 0. So x must be what? Does that make sense to everybody? So if a fraction is 0, it can only be 0 when the top is 0, we're done. Finished. The question is, when is a fraction undefined? When would any fraction be undefined? When the bottom is 0. Right? So set the bottom equal to 0. Now, you have mastered the beauty of factoring. Why don't you come up with the answer? Go ahead.
-9, positive 7.
Okay, so let's see. This is what? You put the top equal to 0 and you get, you put, I'm sorry, you want two numbers. This is x and x. The product is c, negative 63, and the sum is b, negative 2. So what do you have?
Negative
X minus 9 and plus 7. Therefore, x equals 9 and minus 7. So I want you to pay attention to the question. What makes this expression undefined? The answer is what? 9, negative 7. Is that working? Now, the following question is related to that. What is the domain? And before we answer it, remember the simple definition was all possible values of x, meaning the first coordinate, meaning the independent variable. So whatever x can be, we are in good shape, right? So what makes this expression undefined? Whatever makes the denominator 0, 9, and negative 7. What do you think the domain is, everybody? Say it again.
Like, I was thinking negative 7, 9. That's wrong.
Let me just put what you said. These are the answers. Please do not write that. Is this the answer? We just said that makes it undefined, so how could it be the domain? Do we truly understand the meaning of a domain? So one more time, a simple definition. Whatever x can take, simply put, any value of x that works out, that would be considered the domain, a collection of that, right? What does 9 and what does negative 7 do? It makes it not work, right? In fact, it can't get any worse. So the answer is this. So the proper notation would be x such that x is not 9, x is not negative 7. Do we see the relationship between what makes it undefined, what makes it a domain? They are complementary events. Do we understand the meaning of a complementary events? Two things that they have nothing to do with each other and they add up to give us the total set. Okay? Meaning the universal set, in which case is the set of real numbers. All right. The proper way using interval notation would be negative infinity, comma, negative 7, union negative 7, comma, 9, union 9 infinity. I hope you realize the parentheses make the end points, namely -7 and 9, not included. Perfect. So, this is fine. This is fine. Many people are interested in the interval notation. So you want to follow that, but do we understand what's going on here? Go ahead, please.
You know, you wrote after union, the first union, -7 and 9. I don't understand why you would put that in brackets or.
There's nothing in brackets.
I mean parentheses. Because
The
I thought it was
reason
like
why.
-7 to 9. Oh, okay.
Every number is acceptable. If you look, in other words, here's the answer. Let's take a look at the number
That
line.
doesn't include, okay.
Here's the number line. -7, +9. What do you have there? You have a hole. Meaning, is this okay? Yes. How about this guy? How about, everywhere you go, you have no problem except at 2 points. So if you were to graph it, would be all the real number lines except those 2 points. Point x equals -7 and x equals +1. Any questions? Good. I'm going to assume we know how to multiply rational numbers, in other words, fractions. Therefore, we use the same concept to multiply rational expressions. So let us start with a simple case of 3x over 5y squared times y over 9. Okay? Now, remember when you multiply two fractions, you multiply the tops and you multiply the bottoms. Multiply the bottoms. Is that right? Okay, class? Now, before you multiply, we want to simplify, class, because it makes life easier. So here's the answer. You look at the numbers. Do you see they cancel each other? Yes or no?
Yes.
Okay. Do you see that they cancel each other? And they give us y here. So whatever is left is the answer. The top has x, and the bottom is 15, 5 times 3. 15y. You're done. Would that work for everybody? Simple. Whatever you do to numbers, you do to expressions. When you want to add them, subtract them, multiply them, divide them. Right? Sounds good? The next question, class. Let's call it number 2. 2x squared plus 8xy over x squared plus 4xy plus 4y squared. We want to multiply this by 2x squared plus 7xy plus 6y squared over 4x squared plus 14xy and then 12y squared. Okay? Just make sure I copied it right. Oh, 8xy. I dropped the 8y squared in class. All right. I hope you realize I can't do this if I don't know factoring, right? So the assumption is you really have learned your factoring. So let us start with the first one. Look at the first one and the first one only. What comes out first? Anything. 2 is the GCF, is that right? So 2 times what?
X squared minus 4xy.
I think it was plus unless I copied it right. Yes, copied it wrong. Right? So this becomes 2 times what? Now I'm just looking at the top. Is everybody with me? Never mind the rest. So I'm going to completely factor it. Is the top done? So what else can we do?
2xy. X plus 2xy. Parentheses x plus 2x.
How about x plus 2x plus y?
Or y.
2y squared. Would that give you the answer? And why is that? X squared is a perfect square of x. 4y squared is a perfect square of 2y. Does the middle term work? I'm assuming you know a plus b squared. I hope you realize if I don't know a special product, and now we call it special factoring, I'm in trouble. That's just that simple. All right, let's go to the bottom. What is that?
It's the same thing.
Same thing, right? Okay. I'm going to go to the next piece. Class? I don't see any GCF, do you? So I'm going to stick with what I see. By the way, one thing that might help. First of all, this is 2x squared, so you have x and 2x. Everybody agrees? Secondly, this is y squared. So in order to, in a sense, make your life easier and just pay attention to the number 6, just write y, because y times y is y squared, isn't it? So all I'm worried about, at this point, I'm worrying about b, which is 7, and c, which is 6. Do you see that? So I don't have to worry about y squared. I took care of the business. So because I put a 2 here, I can't say, okay, let me see a, b, c. Just look at c. Right? And cut it into pieces 1 and 6, 2 and 3, and make it work. Right? Anything works? What should I put here?
1 and 6.
If I put 1 and 6, it works? Really?
3 and 4.
Do you? You want 7xy, right? Okay. Just since you mentioned, if I put 1 here and 6 here, what do I get? I get 2xy and 6xy, which is 8xy, and it doesn't work. Do you see that? So you said 2 and 3. Where do you put it? Where do you put the 2?
Right there.
Right there. And where do you put the 3? Notice this is 4xy and this is 3xy. They add up to 7xy. I hope you realize it's just a matter of arithmetic. Play with the numbers. The trial and error. Does that work? Or use the other 2 methods I mentioned. Now, the bottom, before I put it here, first I take a GCF because I see a GCF. Do you see one? 2 times what?
X.
2x squared
6.
plus 7xy plus 6y squared, which gives you the same thing, right? Again, this was a simple case, to be honest with you. When you take the 2 out from the bottom, you see that they cancel each other. But the reason I chose this question, because it had factoring, in a sense that I wanted involving x, involving x and y. Now, cancel whatever you can and see what's the final answer. Anybody can see the final answer? What is it? Cross whatever you can. I'm not going to do it. Let me see if you can see the answer. Say it again. Everything cancels out. Is that right? Class 2 and 2. This guy and this guy. Okay? They are identical also, and therefore you end up with nothing. Meaning what? 1. Remember, when you cancel something, you really have to put a 1 there. If it's going to make it crazy, too many 1s, don't put anything but understand. It means it's there. Everybody's okay with multiplication. All right, let's do one more, but this time is a division. All right. Again, if I'm comfortable with factoring, this will work. So I'm going to start with the first fraction, everybody. And I'm going to look at the top. What do you see at top? R squared minus 16, right? Anything comes to mind?
R plus 4 minus
Say it again.
R plus 4, R minus 4.
The top is a squared minus b squared format, isn't it? So r plus 4, r minus 4. I'm looking at the top. There's nothing else I can do. I'm completely done with my factoring of the numerator of the first fraction. Does that work? Okay. Let's look at r cubed minus 64. Any format?
The cube.
Okay, tell me the format so I write it here to refresh everyone's mind. What do you see? A cubed
Minus B cube.
minus b cubed. So what is that, everybody?
A minus B.
A minus b.
A squared.
A squared
Plus AB.
plus ab
Plus B squared.
plus b squared. So if we are comparing it to this format, what is a here? A is
R.
r. What about b?
Minus 4.
Say it again.
Minus 4.
4, you want to say. You don't want to say. But if you're going with this, it's 4. So it's 4 cubed, therefore b is 4. Do the math, give me the answer.
R minus 4.
R minus 4, clear, right? Now I want a squared, so what do I need?
R squared.
Now I need plus ab.
4R.
Now I need plus b squared.
Plus 16.
4 squared, which is 16. Does that work? Now tell me, everybody, what happens when you divide fractions? Explain this one to me.
The division changes to multiplication and the reciprocal changes. It flips.
Perfect. So this guy comes at top, doesn't it?
Yes.
Okay. For now, I'm going to tell you it can't be factored out. After I factor everything, I explain to you a method that will help you see why. So the bottom goes up, and you just write it. And by the way, some of you may see the same thing here, right? You don't even have to factor, it's identical. But I'll tell you why it can be factored out in a second. The top becomes the new denominator, is that right? The top is r squared plus 8r plus 16. What is that? You know a special product, therefore you know a special factor. And if you learned it for the sake of exam and you forgot, you did yourself a disservice. Because it's not going to go away. Don't learn it for the sake of exam. So, what's the answer?
X plus 4 squared.
One more time.
X plus 4 squared.
X, and I don't see X.
I mean, R.
Good. Class? You better remember this. Because believe it or not, this will not go away even if you hate it. It will not. Not in math. Learn it now for your own sake. Got it? I know some of you learn this stuff for the sake of the exam. It's not gonna cut it. Trust me, the final is comprehensive. Everything will be asked. Learn it for your own good. All right. Let's go back. R squared plus 4R plus 16 is a prime polynomial, cannot be factored out, okay? Now, how do I know that? Just by looking at it. Here's how you know it. What I mentioned before, and I'm going to repeat it here. I think we can erase this. It's coming up. I hope you know it by now because you've seen it in other courses. Quadratic formula. Give me the X into it. We've learned it before. I have put it up at least 2 times, and it's coming up, but I was hoping that you're interested to remember it. Anybody? Ax squared plus bx plus c is equal to 0. Okay? A quadratic equation. X is minus b plus minus the square root of b squared minus 4ac over 2a. I don't know why you don't remember it from elementary algebra, but I'm telling you, you're going to need this for the rest of your educational life, as far as science courses are concerned or other math courses. Learn it now. See, you learn something for the sake of learning, not for the sake of the moment. And that's a huge problem. Because no matter what we do here, you may even end up with an A+. But if it's just temporary, for the next just few weeks, and after that you forget, it's really going to defeat the purpose. Learn it deeply. Now, b squared minus 4ac is called a discriminant, right? And in chapter 8 we discuss it with details, what it does. Remember, when b squared minus 4ac, which is the discriminant, when it's positive, you have 2 real solutions. Do you remember that? When it's 0, you have 1 real solution. And when it's negative, you have no real solutions or 2 imaginary solutions. We discuss complex numbers also in the end of chapter 7. Roots and radicals. Okay. Now, one more piece of information. If this is a perfect square number, for example, 25, 100, 36, it comes out of the radical, is that right? If it's a perfect square, then the expression can be factored. Is everybody with me? Can somebody, okay, can you see, go back up here. What is A? Everybody, what is A here? A is 1. Variable is R. By the way, X is a dummy variable. You could have Y, Z, R, who cares, right? Everybody knows that. Having said that, if you're looking at this expression, A is 1. What is B? 4. What is C?
16.
Okay. Now, take a look at, calculate B squared minus 4AC. Calculate B squared minus 4AC. What do you get? Come on. Split second should have the answer. B is 4. Square it becomes 16. Minus 4 times A is 1 times C is 16, which is 64. So 16 minus 64 is negative 48. By the way, even if it were negative 36, it's negative outside of the bit. It can't be factored out. Do you see that?
The negative.
Okay? If it's negative, it can't be factored out. If it's positive, it has to be a perfect square. All right? So, can you give me the final answer now? Simplify everything. What do you see left? Right? Right? By the way, it doesn't matter. You pick one from the top, one from the bottom. Which fraction? Who cares? And so what do you have? R plus 4 and R plus 4 squared. Do you see that this goes away and the exponent goes away, right? So what do you have at top? Since I didn't put anything, that means 1. That's the final answer. And I hope you realize the importance of knowing all the basics we've learned. The beauty of math is all accumulative. You learn something, you can't afford to lose it. You just can't. Okay? All right. I want to look at equations. All right, let's look at a simple equation involving rationals. If we look at the following. Oh, I'm sorry. Let's look at addition before we look at equations. 5 over x. A simple case. How do we add? In order to add fractions, you have to come up with LCD, which stands for?
Lowest
Least
common
common.
denominator.
Okay. Can you see the LCD here, class?
2x.
2x. So if this is 2x, the first one doesn't change. Everybody agrees? What do I need for this one to have the denominator 2x? What is missing here?
2.
Do you see that I need a 2 here, and therefore I need a 2 here? So the top becomes what?
10.
2 times 5. And so the answer is what?
13 over 2x.
Simple. Everybody is okay with that? Good. All right. Let us look at this simple question. All right, let's see what we need. First of all, let's find the LCD. What do you think LCD is? Let's write the
40.
first fraction. 8, x to the power of 4, y, and 5, x squared, y cubed. Do you see 8 and 5 gives you 40? Okay. Do you see x to the power of 4 and x squared gives you x to the power of 4? You pick the highest exponent, don't you?
Y
What about the
cubed.
y's?
Y cubed.
So you're done with your choice of LCD, is that right? So what do you do now? In order to raise this guy, you have to divide the LCD by the first denominator, right? So what do you need here for 8 to become 40?
5.
One more time, 5.
Y cubed. Y squared.
for x to the power of is there, 5y squared. Do you see that? I'm dividing 4dx to the power of 4y cubed by 8x to the power of 4y, so I need 5y squared. So what's the top, everybody? What's the top?
15y squared.
All right, let's move to the second piece. What do I need here?
8x squared.
So I need 8 to make 540. Then I need x squared to make x squared x to the power of 4. Y cubed is there. I don't need it. So I need 8x squared, and the answer is what?
8x squared.
And believe it or not, you're done. End of this story. Very simple. Sounds good? Everyone?
You never simplify?
What do you want to do? You just want to add. Why would you want to simplify? The question was, okay, how do you add? Wasn't simplification. There is nothing to simplify. And by the way, by simplification, what do you mean by simplification? There is nothing that is in common that you can take out. Okay, let us look at this question. And notice, to come up with LCD class, we need to factor all the denominators. The first one, can I factor it? Done. The second one, can I factor it? Look at the last one. Is there any GCF? The last one. 3 is a prime number, yes? So x and 3x. Now all I have to do work with C, negative Tony, and cut it into pieces. Bless you. I can cut it into pieces, 1 and 20, 2 and 10, and you continue. Sometimes, class, there may be a hint here. Are you with me? Sometimes it's not. In fact, most of the time it's not. But take a look. You can never go wrong. So what do you think we can do, class? You're factoring. You just finished the exam about factoring, and I'm just giving you a hint. So factor is this. What do you get? You can do it. I just gave you a hint. Did you hear the hint? Okay. Say it again.
X minus 5. 3x plus 4.
Now, does the middle term work?
No.
Minus 5 times 3x is negative 15x. 4 times x is 4x. They add up to negative 11x. It does work, doesn't it? Everyone? Give me your LCD. Right? Now look at the first one. Do you see that I need x minus 5 here, class? Yes or no?
Yes.
So the top is what? X times x minus 5, isn't it? Give me the second one. What do you need for the second one?
3x plus
The same sign. 3x plus 4, right? Times what? 3x plus 2. Does the second one works? Yes? For the third one, I don't have to do anything. Don't forget the sign is negative. And do not forget to put it in a parentheses or right now apply it to each piece. Everybody is okay with that? All right. So here's the fraction up top. Let me write the denominator first because it's in a factored format. All right. First piece, what is this?
X squared minus 5x.
X squared minus 5x. Second, multiply and you can come up with the answer fast. You don't have to FOIL it. I hope you can do this fast. So, but FOIL it in your mind and give the final answer. Do you see it's 9x squared? Yes? And then 3x times 2 is 6x, 3x times 4 is 12x, so it's plus 18x, yes? Do you see the middle term is 18x? And then 2 times 4 is 8, yes or no? Finally, let me use a different color because I have a negative sign. I want to make sure everybody understands it applies to everything. Minus 7x squared minus 24x minus, I'm sorry, plus 24x because negative times negative. Minus 28. Is that right, everybody?
Yes.
Okay. So now, combine like terms and give me the answer. X squared, 9x squared, minus 7 squared is what? 3x squared. Okay. Minus 5x plus 18x plus 24x. 37x. And what do we have?
Negative 20.
Minus 20. Is that right? So we have, let's see, x squared, 9x squared minus 2, 3x squared minus 5x and 18x. There is 7x and minus 2. So 3x plus 4, just make sure we had. Okay, I'm sorry, class. It was plus 24x. I copied, was plus 24x. If you change that, and that becomes minus 24x. So this has an effect over here. Let's go. Did I write 24x originally? Or did I put negative 24x? What was the original question I put up for?
I had plus 24x.
Plus 24x, okay. Then if it's plus 24x, then this becomes negative 24x. Right? Because I thought it was negative. Okay. All right, so now it's what? Minus 5x plus 18x minus 24x. What is that now? All right. Let's write the factored format for each piece. The denominator is in factored form. So the top is 3x squared minus 11x minus 20. Okay? So remember what that was?
X minus 5, parentheses, 3x plus 4.
And everything cancels out. By the way, they don't have to cancel out, okay? Just whenever you look at the final answer, you see if there's anything that you can cancel. All right. Let's look at complex fractions. All right. Those are examples of complex fraction. What do we mean by a complex fraction? We mean a fraction within a fraction. That's the simplest definition. Now, what's important to understand is what it means. So I'm going to look at the meaning of a complex fraction and take that route to simplify it, because you can never have an answer which has a complex fraction as the final answer. Never. In any case. So how do we simplify? Let's look at the meaning, and then I show you the easy way out. Here's the meaning, class. What is the meaning of a fraction bar to you? Fraction bar, which operation does it represent? Do you see that? Everybody knows fraction bar has a meaning as far as the operation is concerned. What operation? Division. So this is the same as dividing by 7. So how do you divide this? 2/3 times 7 over 1, which is 14/3. You can leave it. Of course, you look at it, see if you can simplify it. Can't be simplified. You can leave it or write it as a mixed number. Go ahead. But I'm going to also show you the fastest way.
When it's divided by 7, to multiply it, it would be 1/7, no? Because 7 over 1, you have to make simple.
When you divide by any number, as far as fraction, you have to multiply by the reciprocal. That's the meaning of the
Yeah,
division.
so 7 over 1, and then you have to flip.
Yeah, 7 means, this is 1/7. I'm sorry. You're right. 1/7, which is 2/21. All right. You're right, thanks. Let's do the second one also, and then I'll show you the fast way. If you look at the second one, it's 3/4 divided by 5/8. What does that mean? 3/4 times 8 over 5. Yes, class? Which means you can simplify the 4 and 8 first, and the answer is 6 over 5. Okay? Now, I wouldn't take this route because there's a slightly faster way. Which is, when you have a complex fraction, if you end up with exactly one fraction at top, one fraction at the bottom, you can do this method. First of all, make sure this is one fraction. The bottom one is not a fraction, make it a fraction. Is everybody with me? Then multiply the extremes, 2 times 1, and put it at top. Multiply the means and put them at the bottom. Do you see it's the same answer as 2/21? Now look at this one. Extremes, they come at top. means, look at this one. If you look at this expression, this product, you see it's identical to what I wrote here. Isn't it identical? And then you simplify, of course. So that would be a fastest way. When can you use that? Only one fraction at top, only one fraction at the bottom. For example, you cannot use it here. Okay? So what do you do over there? There are two ways. And I'm going to go over the second way because I'm going to assume you know the first way. So let us quickly discuss the first way. And then we go over it. Well, maybe I quickly show you both ways. Okay, both ways. The first method, class, assume you don't have a denominator and just work with the top. Are you with me? So when you don't have a denominator, you need a common denominator for the top. So I'm going to use two different colors. Let's use the blue for the top. And we are using black for the main fraction one. So the top, what is the LCD? Only the top is x squared, isn't it? So do you see that this is 4 times x? And this is 2. Everybody understood what I did? So I need what? X over x. Now for the bottom, can you see this is over 1, and therefore x is a common denominator. This becomes 2x, and the other one remains unchanged, right? Everybody can see what I'm doing? This one is what? X over x. Yes?
How did you get the 3 on the top?
X squared. This is not 3. This is x squared.
4x plus 3.
It's 2.
It's 2.
Oh, that's it. Yeah, over at the right, where you have it in the red, it looks like
It's a 2.
See, when you take a common denominator, it becomes the second denominator. The numerator you multiply by x becomes 4x. And the second one, you don't change it. So this is 4x plus 2. But this one, you need to multiply by x. Does that work?
Yeah.
So what do we have now? Now we have this case where we can write it as a fraction such that you multiply the extremes, which is x times 4x plus 1, right everybody? At the top, and you multiply the means, and so you write x squared times what? 2x plus 1. This was 4x plus 2. All right. Now I'm going to erase this part. Okay. First of all, we can drop the x and make this x squared x. Secondly, we can take the 2 out, becomes 2 times what?
2x
Plus 1 over what? X times what? 2x plus 1. So what's the final answer to this?
2 over x.
So that's a method I wouldn't use, but I just wanted to show you how it's done. How is it done? You simply add up the top only until you're done. You add up the bottom until you're done. Now you deal with a complex fraction the way we had it, and you come up with the answer. Here's the second method, which is much, much faster. Is everybody done? Because I want to erase that. Now, what we are going to cover today, what we have been covering, if you go over that, that would be the whole chapter class. Okay, I'm going to. I hope I have time to finish the other 2 topics that I have in mind. All right. So here's the second method. fractions do you see? The total of 3, right? Doesn't matter how many. You have 100. You have 5. You have 6. All of them. What is the LCD? Anybody? 4 over x, 2 over x squared, 2, and 1 over x. What is the LCD?
X squared.
So multiply the top and the bottom both by the same LCD x squared. Is everybody with me? So here's what I want you to do, class. I want you to ignore the bottom for now. And I want you to multiply the top by x squared. Can you see what you get? And by the way, if it helps, put x squared over 1. So what do you get? 4x. Because x squared cancels out x and it gives us x times 4. Continue.
2 plus 2.
Plus 2. Do you have to do anything else to the numerator, to the top? The top is finished. What about the bottom? Now we want to do the same thing. We want to multiply the denominator by x squared, and if need be, put x squared over 1. So what is that? 2x squared plus what? Plus x, isn't it? Because x squared and x cancel each other. So I'm not finished, but can you see how fast we got to this? Can you see that? Easy way out. Now we're going to factor. What is the top? What can we do? 2 times what?
X squared plus 1.
X plus 1. Okay. And the bottom, what comes out? Times what? And it gives us the same answer. Sounds good? All right. Let's look at equations. And let's start with this very simple example. Now, when you get an equation, a rational equation, generally speaking, you want to get rid of the LCD. If it so happens that you have 1 on each side, the cross product will do it. But anytime you have an expression at the bottom, you must exclude it. So before I start, I say over here, what's the problem? -1. So can you see -1 is not an acceptable answer? Do you see this one, x can't be what? So you write that first and foremost. Why is that? In case we come up with any of those answers, we exclude them. Everybody got that? Now in this case, I can use a simple case of a cross product. 3 times x minus 3 and 2 times x plus 1 are the same. Cross product. This is what? 3x minus 9. This is 2x plus 2. Move the 2x to this side. Move the -1 to the other side. And then you check. Now, how do you check? A long way to check is simply put it back into the original investment. A simple way, if by any chance you trust yourself you haven't made a mistake, make sure those numbers are not the answer. So you check with the numbers that you excluded. So what numbers do you exclude? -1 and +3. Does that work for you? All right, let us look at something a little bit more involved. First of all, class, when you are doing a rational expression, make sure you know what is excluded. In order for you to know it, you have to know factor. So, if you were to factor the first one, what would you get? And I probably stop at this point because there are a couple more topics that I'm going to look at, but I'm going to look at it tomorrow with some graduates because I want to make sure you have enough time to digest this stuff. So this is the last question we're going to do. Quickly, factor the denominator. What do you get? Anybody? X plus 4, x minus 2. Factor the denominator. What do you get?
X plus 5, X plus 4.
Last one. X plus 5 and what?
Minus 2.
I hope you realize the importance of factoring. So we know factoring, we have no problem with that. Does that work so far? Before you start, you must do what? Exclude whatever is in the whatever makes each denominator 0. So class, x cannot be what? You tell me and I write it.
Negative 4,
Negative 4,
positive 2,
positive 2,
negative 5,
negative 5. We wrote that or no? We already wrote it, right? How about this guy? We have it. How about this guy? We have it. Do you see that? So we know whenever we're done numbers, negative 4, 2, and negative 5 are unacceptable, right? By any chance we end up with any of them, that would be an extraneous solution and unacceptable. Does that work? In order to solve this, there are two ways. One is to simplify the first and then set it equal to the right and do the cross product like this. Or the easy way out. Clear out the what? Clear out the denominators. So let us multiply both sides by what? Both sides is different than raising fraction. Both sides by LCD. Can you tell me for all those fractions, there are 3, what is the LCD?
20,
X plus 4, X minus 2, X plus 5.
X plus 4, X minus 2, X plus 5, right? Notice the way I have it. You can either write it on both sides or just put a huge brackets, set up brackets, and put this on one side, meaning what? I'm multiplying every piece by the LCD. Does that work? So here's what I want you to pay attention. Everyone, just look at the first one and multiply it by this. By the way, you may write it as this. That has the same meaning, right? So if I'm multiplying this one by the LCD, can you see the answer is 2 times what?
X plus 5.
Everything drops out except x plus 5 and I'm done. Is that right? If I'm multiplying this guy, it's minus what?
minus x,
X
Minus 2.
minus 2. Does that work? What about the right side? The right side.
4 times X plus 4.
So what have I done? I have changed a rational equation to a simple, a linear or quadratic, in this case it's linear, equation, and everybody knows how to solve that. Do you see how fast we get there? Multiply by LCD. So let us quickly finish that. This is 2x plus 10, right class? Minus x plus 2, and this is 4x plus 16. Left side is, let's just write it here. Left side is it x plus 12? Yes or no? And this is 4x plus 16, right? So if you bring this one to this side, it becomes negative 3x, and this becomes 4. Therefore, x is negative 4/3. Does that make sense? I will take it from here tomorrow. We will look at word problems, a class of problem called work problems. I'm going to look at that. And I'm going to look at formulas, okay? Somebody has asked, we're going to go over that, but I just want to make sure you digest what we have covered. I don't want to cover too much. So we will go over that and roots and radicals. All right, class. Have fun.
We're going over.